Hello, welcome to this presentation. My name's Andrew Dowdy and I'll be presenting the results from Project 2.8, Extreme Weather Projections. The project covers the Bureau of Meteorology and CSIRO, as well as 4 unis, with a focus on extremes and disaster risk reduction. The problem addressed is that natural disasters are commonly associated with extreme weather in Australia, and these weather extremes and the costs associated with the impacts are likely to change in a warmer world. Project 2.8 addressed significant knowledge gaps on 4 major types of extremes, including tropical cyclones, bushfires, thunderstorms, and east coast lows. The project research included a novel method for indicating tropical cyclones in climate model data based on their environmental conditions. The figure on the left shows that the method successfully reproduces the key features of the observed tropical cyclone climatology, including their genesis, track clusters, and direction of travel. The figure on the right shows new projections using this method, with fewer tropical cyclones in the future for the Australian region. In particular, the results show a stronger reduction in numbers around Western Australia than Eastern Australia, with this being a consistent finding for the different model methods shown here. The reasons for the spatial differences in the tropical cyclone projections were examined further, including in relation to future El Nino and La Nina events. So this figure shows that the reductions occur for both El Nino and La Nina conditions around Western Australia, but only for the El Nino conditions for Eastern Australia. And these results published in Nature Climate Change, and this helps address knowledge gaps around spatial details in the tropical cyclone projections for Australia. A tropical cyclone web portal was produced to summarise and communicate the new data and information. This kind of information on future projections was not previously available online. It includes a user interface that allows interaction with things such as their tracks, densities, and coastal crossings. And we've got positive feedback from stakeholders on the portal, including Great Barrier Reef Marine Park Authority, who said that it's helped them have a better understanding of regional differences in the projections. The new bushfire research included the production of a data set of the Forest Fire Danger Index. This measures the dangerous weather conditions and drought conditions are relevant for bushfires in Australia. The data set is from 1950 to now and is updated automatically each day. So we can now make maps such as this one shown here, and this new capability allows us to confidently say that many recent events are actually much worse than those previously experienced. It also enables trends to be examined in more detail throughout Australia, and for the first time we can now confidently demonstrate that recent changes in fire weather conditions are attributable to anthropogenic climate change in some regions. Projections of future changes in fire weather were produced, and these projections are based on daily data from 15 global climate models combined with downscaling for 8 CCAM and 12 WRF-NARCLIN ensemble members. This is more comprehensive than what was previously available. An example is the Climate Change in Australia projections used 3 GCMs for bushfires and just applied the monthly mean scaling to historical FFDI data. In addition to the FFDI, projections were also produced for C. Haynes index, and this index represents pyroconvection conditions, such as occurred on Black Saturday in the Canberra fires, where thunderstorms formed in the fire plumes. And this can make bushfires more dangerous. And some of the project research showed that thunderstorms for Black Saturday fire plumes generated lightning that ignited new fires about 100 kilometres ahead of the fire front. The figure presented here shows projections of the Forest Fire Danger Index for global climate models, CCAM and WRF downscaling approaches. And 2 measures of severity are shown for FFDI greater than 25 and also FFDI greater than its historical 95th percentile at a given location. And it shows that the results are very clear, with increased fire danger for Australia due to increasing emissions. The project examined east coast lows based on different levels of the atmosphere, and shown here is an example of our findings, and the figure shows that the strongest winds are actually caused by cyclones that are well defined over a deep range of levels through the atmosphere. And this is an important result because most previous studies have only examined east coast lows for a single level of the atmosphere. Research on east coast lows also considered their energetics, including whether they had a warm core, as is the case for tropical systems, or a cold core similar to extratropical systems. And a third type was also considered for hybrid events, consisting of a warm core near the ground and a cold core at higher levels. This method was tested on some high impact east coast low events, and then subsequently applied to all time steps of the ERA interim reanalysis data back to 1979. This method helps us understand the factors that drive the formation of the high impact east coast lows, which is important to understand in relation to how those factors might change in the future. And we've also produced projections of this method for the future east coast lows. In relation to thunderstorms, we managed to get a new data set made available online for a nationally consistent grid of lightning density. And this has subsequently been used by a range of stakeholders, including for the energy sector, finance sector, emergency management sector, as well as by Standards Australia for an update to the national standards used for infrastructure design throughout Australia. Thunderstorms were also used in an integrated approach to examining storm impacts. This was based on combining data for thunderstorms, cyclones and fronts, together with rainfall and wind data. And the results show that the highest risk of extreme rainfall is due to a type of triple storm defined by the simultaneous occurrence of a thunderstorm, cyclone and front. These compound events are the most frequent cause of extreme rain near the east coast of every continent in the world, as shown in the figure here for the grey regions. The results also show that the mid-latitude regions of the world are where the compound events are most important, including for Australia. A number of synthesis products were produced to help translate the project research, including some review papers written on tropical cyclones and on east coast lows, as well as a broad review paper on all types of Australian natural hazards in a changing climate. Targeted synthesis products were produced, including for the 2018 State of the Climate Report and also writing of the IPCC 6th Assessment Report. A set of brochures are also in production, covering the project's 4 components of tropical cyclones, bushfires, east coast lows and thunderstorms. The project outputs are being used by various stakeholders, including state and federal governments. And this included a briefing of the Prime Minister on extreme conditions during 2018 and by Grabumpa for the tropical cyclone projections, as well as many other examples. Project outputs are being used by energy sector groups, including AEMO and Electronet, and by finance sector groups, including insurance and reinsurance groups. Project outputs are being used by Standards Australia for revisions to national standards for lightning risk and also national standards for extreme wind risk. That's important for infrastructure and building design through Australia. Other researchers are using our project outputs, including INCLEX, the ARC Centre of Excellence for Climate Extremes. The project's communication products have enabled outcomes for a number of sectors, including for the emergency management sector. Project research and synthesis products form the scientific foundation of AFAC's discussion paper on climate hazards, with AFAC being the Australasian Fire and Emergency Services Authorities Council. The document on climate risks shown here for the emergency management sector was approved by AFAC Council in 2018. And this is now producing changes in practices for the emergency management sector throughout Australia with on-the-ground benefits. For example, state fire agencies and emergency services are now aware that past practices may not always be applicable due to climate change. And the project outputs enabling evidence-based decisions to be made on how different types of natural hazards are changing in regions throughout Australia. And this can help result in enhanced resilience and improved climate change adaptation efforts. So we're seeing that interest in climate extremes and hazards is increasing and is expected to continue increasing. And although we've addressed many knowledge gaps in this project, there's still many remaining, and more research on climate extremes and hazards is therefore valuable for Australia. And now that this project is finishing, the next steps to build on the completed research from this project is a shift towards more onto the hazards rather than on the phenomena such as cyclone and thunderstorms that cause the hazards, as was the focus of this project 2.8. So the new project 2.5, which will start in July this year, will also have an emphasis on stakeholder engagement to enable the evidence-based policy and planning. Well, that's my summary for project 2.8. Hope you have enjoyed it. If you have any questions, feel free to contact me. Thank you.